concerning another field of research, not from battle of model years. We saw this very interesting reports. In principle, we have a big problem in this time with analysis of future of number data published in different journals, scientific journals. And such information is collected, PubMed. I think you all very well know this information. And you can see the increase in the body of literature data like exponential, has exponential type, and to read all this, not full length papers, but also to read only extracts from PubMed, we need about more than 300 years. And I think during time when we will read these papers, new paper will be arising. It is impossible to read all papers. And one way to analyze such a huge number of data is development and implementation using computer systems that analyze text and extract facts, some informal way, and present these facts in some databases or knowledge base. We have developed such system in Silent Video, Associative Network Discovery System, that allows user to automatically extract knowledge from text and represent this text in database and will visualize this database as network, as a certain network. And this is in this slide we can see common schemes which are implied in our system. First of all, we prepared ontology for biological field. Ontology included some dictionaries of objects and dictionary of relationships between objects. And also our system contained text mining model that based on shallow parsing and analyze text. In this implementation, we analyze abstract from PubMed, but we just in this time we try to analyze full text papers, and I will show later about our results. And the source of information may be PubMed database or full length papers. And also we integrate information extracted from text with information which we taken from databases such as Intact, Mint, CBI, Gene, TRT, and so on. And this information are presented in NCO knowledge database, and we have some visualizer, assessment, visualizer and video system. Visualize. A pipeline of text processing used in the text mining model presented in this slide. First of all, we convert the text in our format, convert to the text. If this is a PDF file, can be PDF file, the PDF file will be converted to the text. And then we split the text in the sentences. And in each sentence, we process each sentence different to each other and recognize and make names in the text. And we use template approach, shallow parsing approach, semantic templates to extract information and relationships between objects presented and self-data knowledge base. And we use, first of all, we need to create dictionaries of objects, and we use databases, such databases as Andreas Gene, SwissProt, to extract basic names of objects, and then we expand names of objects and adapt these names to free text using PubMed text. And we use some steps for expansion of objects, of dictionaries. And we use dictionary for protein names, gene here is some scheme of expansion of number of synonyms for names of objects by comparing with the normalized text. We use basic names and we make some normalized text from this normalized names from these basic names, and also we normalize parameters and then compare these names and we get synonyms. This is some example. This basic name, new synonym, better cell, and so on. And second type of expansion of number of names is searching for terms in text using vocabulary of names. We developed slightly three methods, special method for extraction of terms from sentences. This is some fragment of sentence which has some semantic, some sense, and then we classify these terms on names, and these names new names use as synonyms for basic names. You can see we use keyword cells, and we can extend our dictionary of cells by these names, which are not presented in any basis, in databases, but is presented in papers. And we extract these new synonyms from paper. This is ontology of molecular genetic interactions, direct interaction, physical interaction between two objects, catalytic reactions, conversion, chemical conversion, one substance to another substance, some events such as cleavage, concentration, treatment, and different type of regulation, up-regulation, down-regulation, regulation function, regulation expression, regulation degradation, regulation of transport, of phosphate function, regulation of diseases and processations. More than about 30 different type of interaction we consider now in our system. And this is some representation of how semantic templates work. Semantic templates is contains some meta information about interactions, because we use some regular variation for extraction, and in template contains meta information about this regular expression. For example, we included in template inference about dictionaries. Object 1 is any name from organism dictionary, object 2, and so on, so on. And meta information about relations. Relation 1 will be object 2 down-regulate expression of object 3. And this is defined in this regular expression. And relation attribute, object attribute, object organism, and other type of meta information. And our task is find names for these objects only. Using analysis of text, we identify that object 1 is hepatitis C virus from this sentence. Object 2, core protein. Object 3, this name. But interactions type and other both included already in semantics templates. Okay. The information extracted from a sentence can be presented as network. And here is some statistic about number of facts extracted from database and PubMed. Databases and PubMed. You can see that from databases we extracted about 3 million facts, from PubMed about 40 million. And here is accuracy estimation, and we can compare accuracy for processing of PubMed and accuracy for processing text processing of full-length papers. And we define the full-length papers. Our precision was 90%, automatically to analyze this information is difficult problem, and just now we come to this. And if we include this information from total recall will be less only 30%, because some information not included in the text. We will come to extract in the text this information. But if we will consider only that those proteins which are described in the text, we can get about 40%. But full length paper recall is more, but is high, but not so high. About only 5% we can get, but this is expensive, because we need to get full papers. It's not, sometimes it's not free, it's a headache, and we can use but not loss. This is our tool for visualization, and I will be short to present some results. We can see a network of diseases associated with hepatitis C. Using the system, we can construct interactions, not relationships, not only between proteins and metabolites, for example, but also relations between different diseases, and regulation. One disease can regulate other diseases, and this information can be from our system. If you will construct some network for human genes and proteins associated with hepatitis C chronic disease, you can get such network. This is a usual case. As usually, if you will analyze the text, we will get huge networks, not small, because I saw in your presentation that we can only see maybe 10 objects in network. It's very clear, but how for construct this network, you first of all you can analyze such type of network, and then only you can. But I think you know very well this. And using some filters, we can construct some network for control, only expression control, and protein control expression of genes, and negative control, it's more clear networks. And we can construct interesting and check some interesting hypotheses about how these two various proteins have interact on human pathways. But is there some pathways in which that some double strike from virus proteins? Yes, we can see that this is basic pathways, and we can, using our system, we can get from a huge network, because an cell is some prototype of electronic cell, because it contains all extracted from us of information from literature and represented as in formal way, and can be presented as network. This is not electronic cell, but some raw material to analyze electronic cell, and we need to extract from this huge net 40 million interaction type between objects, and to extract some subnetwork and pathways, we need to develop some methods and search for pathway. We have implemented this tool, and user can specify first object and last object, and can specify if we want intermediate object, can get this pathway, which will be some template for pathway extraction for a huge network. And, okay, sometimes we can get such type of pathway. This is our PDSoft team,